So this is another of the small recordings we're going to do for this week. And on this one, what I want you to realize is it has changed a little bit. You see that we have the kingdom, phylum, class, order, family, genus, species we talked about earlier in one of the other videos. But what you're seeing is we are now adding another level higher, more inclusive, and that is called the domain. And I want to explain why. And this is kind of a good idea why, or a concept I want to explain because of the way science works. It's slow. I'm just gonna say it's very, very slow at times. Um, and so I had mentioned in the earlier video that there used to be 2 kingdoms. It went to 5 kingdoms, and then everybody was kind of happy with that. And then all of a sudden, there was a guy that came up with an idea. His name was Carl Woese. I will show you him in another on another slide. But he wanted to change things, and so he knew that the biological establishment can be slow, hard-headed, not want to change. And so what he did is he actually introduced what he called a 6th kingdom, which was archaea. He studied this type of what we used to call a type of bacteria, um, and that type of bacteria did not fit well in with the others. So he wanted to pull it out, and he really thought that the hierarchy should be added above, but he realized that people wouldn't go there. So what he did is he actually got the establishment to add a 6th kingdom. And it was great. So it took him, like I said, it was slow. It might have taken him 15 years to convince everybody, hey, we really need the 6th kingdom. And then finally people came around and said, okay, Carl, we'll give you your 6th kingdom. And then when that happened, he had, oh, I'm just kidding. I really want this domain. So then he fought for more years to try to get that. And that is really kind of where we are today, that what most biologists should be teaching is that there are 3 domains, and under the domains there are what we still call kingdoms, but even that name is starting to fall apart a little bit. And so just to give you this idea. Okay, so let's talk about the 3 domains. There's the domain bacteria. At one time that was actually called the kingdom Monera, and I'm not going to hold you that, but Monera was an old term that they used. And Both bacteria and the domain archaea were under that, and this is what Carl got separated. And again, I'll talk about it a little more specifically because they do differ. And then everything else below is made up of what we call eukarya. And eukarya is the type of cells it's made out of, and we'll talk about those cells in a second. And so here we have 3 kingdoms, actually 4 kingdoms, I think. My little heading's on the bottom one, but this would be the kingdom Plantae and Animalia, fungi, and then there's a kingdom Protista, which technically is no longer a kingdom. That has been broken up, and that probably is multiple kingdoms. And again, this is all in flux on how we deal with that. All right, so let's talk about the domain bacteria. The domain bacteria, they are prokaryotic, which means, again, that they have no nucleus and that they have no membrane-bound organelles. Membrane-bound organelles, chapter 6, we'll go over that in a lot of detail, but that would be things you might have heard of in high school. Cells can have things like chloroplasts, mitochondria, Golgi apparatus, lysosomes. I don't know if you've heard those terms, but these are little tiny organelles inside. Well, bacteria does not have any of those. They do have a cell wall. You hear cell walls, that's usually associated with plants. Plants have a cell wall of cellulose, but these guys have a cell wall of a substance called peptidoglycan. So I want you to know that. And this would include most bacteria that you're common with, things like Salmonella, E. coli, all of those are types of bacteria. All right, the domain archaea. It means ancient. And what I want you to know is they are prokaryotic cells, like the other bacteria, like the kingdom or the domain we just talked about. But there are some differences. Up on the left, that is Carl Woese. Let me spell his last name: Woese. And unfortunately, he has passed away a few years ago. But he was the person that really kind of pushed this domain idea through. Um, he picked working on these. They were pretty interesting. They're usually found in very extreme conditions, high heat, high temperature. Many of them produce methane. And so he found them very interesting, but he found them very different than the things like E. coli and those things. And so here's a chart in the book that explains those things. And I don't want you to lose your mind and memorize the chart, but I do want you to realize why he wanted to make this leap. So if you look at the chart, what you're going to notice is archaea and bacteria, the two domains, are made of the same type of cells. Again, they're made of prokaryotic cells. And that is why they were grouped together before. Most of them are unicellular. And so it made sense. But what he found out is if you look at the chart, there are some differences. The peptidoglycan in the cell wall does not exist in archaea. The other thing is if you look down this table, and again, I don't want you to memorize the table, but the way they make their DNA and the way they make their protein, and we're going to talk about all these things this semester, like the polymerases, um, like introns, those kinds of things, histone proteins, all of those are very similar to eukaryotes. And so his idea was that although structurally, if you look at them, very superficially, they're more like bacteria, but the way they make their DNA and the way they make their proteins are more like eukaryotes, more like us. And so he thought that, hey, we need to elevate this to a different grouping. So he got his sixth kingdom, and then he did the domain. And here's what I want you to know about the reason. It's a little hard to understand, especially for one of the first lectures. But I want you to get that when we did the five kingdoms, it was all about structure that you can visually see. Okay, they have this structure or they don't. So it was a structural component that was setting up the five kingdoms. His argument for having a domain system was that we're not looking at physical structures anymore. We're looking at processes. We're looking at actually at the molecular level. So it makes sense to add another group. And so after, like I said, probably 25 years, they finally agreed with them. And now we have the three domains. So again, bacteria, prokaryotic, archaea, prokaryotic. Um, this one has peptidoglycan. This one does not. And then again, these make their DNA and proteins more like us. And we'll talk about that as we go through the semester. All right, and just to give you an example of these, I'm always amazed when I go places. One of the things is you go to Yellowstone. I went there with family and friends, and we're walking around, and there are some great signs. If you've ever been there, there are mud pots and paint pots. These are areas that you can hike through, and they're colorful, and they're very heated up. And actually, I think it was 2 years ago, a boyfriend, girlfriend were up there, and the boyfriend fell in and died. He was basically eaten alive chemically by it. And they have a big sign on the major walk, and it says, "Here you're looking at bacteria," and I'm like, "No, you're not. You are looking at which is an archaea, and it is actually not a bacteria anymore. So that sign needs to be fixed." And my wife's like, "Just shut up. I don't want to hear about it." But her burden, not yours. All right. So again, just to make sure we understand this, the domain eukaryota, they have eukaryotic cells. And so again, this one would have, I should go back, they would have a membrane around the nucleus, and then there was also have some of the organelles. Um, and they're pointing at a mitochondria and some vacuoles, it looks like, in that picture. Okay. So Kingdom Protista, and I'm going to tell you, that's the last time you're going to see me use that. Protista is a grouping today. It's the what I call the grab bag. It's we put the organisms in there that we don't know what to do with, and we called it a kingdom. This Protista probably has 20, 30 kingdoms within it now, and we're not going to worry about it. We're not going to go there. Bio2, we talk about it, but what I do want you to understand is most of them are unicellular, although there are some that are very large and multicellular. Brown algae, kelp would be in this grouping. But if they do have cell walls, they have cell walls of cellulose, very similar to plants. And in this picture here, you can see an amoeba. And then you also see some filamentous, what looks like probably Eulothrix, actually. So that is probably a green algae. This is definitely Eulothrix. This could be a different type of green algae, but not that important for you. There's desmids, So again, this is all Bio2 stuff, not important for you today, but cool stuff. So again, eukaryotic, and if they have a cell wall, it's made of cellulose. Here we have the kingdom fungi. They're multicellular, most of them. There's some that are unicellular, like yeast. But these would be the mushrooms, things like that. They have cell walls, but the cell walls is made of chitin, which is a polysaccharide we'll talk about coming up next week. And these guys are decomposers. Another term you'll hear is saprobes, where they release chemicals to digest things, and then they absorb that material. The kingdom plantae, again, multicellular. The cell walls are made of cellulose, and these are autotrophic. Autotrophs, which means self-feeder, so photosynthesize. And then last but certainly not least is the kingdom Animalia, and these were the three things I gave you when I was doing the hierarchy: multicellular, no cell walls, and then heterotrophic. So we will stop the share, and we will stop the recording.